Deep within the Earth, locked inside rock layers dating back 65 million years, researchers uncovered something that shouldn't be there. Tiny metallic spheres, rare in nature, are scattered around the world in a distribution identical to what we see from modern nuclear explosions. Yet these particles appeared long before humanity ever existed. For as long as we can remember, we assumed we were the pioneers, the first species to split atoms, smelt metals, burn fuels, and alter the air around our planet. But what if that assumption is wrong? What if other advanced societies once lived here, only to have time itself erase nearly all evidence of them? In this video, we'll explore clues that push us to reconsider Earth's past. We'll look at hidden nuclear signatures, puzzling extinction events, and the unexplained voids in the fossil record. Get ready, the investigation begins. Music. In 1980, geologist Walter Alvarez was studying rocks in Italy when he stumbled upon something unusual. A slim band of clay dividing the Cretaceous and Paleogene periods. This band contained iridium at concentrations 30 times higher than normal, while nearly absent in Earth's crust. This rare element is abundant in asteroids. That single finding transformed how science viewed mass extinctions. The iridium layer became the smoking gun of the asteroid strike that ended the reign of the dinosaurs. But what truly intrigued experts was how clearly one cataclysmic day remained visible in the rock record tens of millions of years later. This realization raised a deeper question. If one asteroid impact left such obvious traces, what might the remains of an advanced civilization look like, and could we even recognize them? From this idea grew the Silurian hypothesis, named after a fictional alien race from Doctor Who. The theory asks whether technological civilizations could have existed long before humans, leaving behind only subtle or distorted traces that geological processes have since hidden. To grasp the scale of the problem, consider deep time. If our industrial age lasts 10,000 years and then collapses, that slice of history would represent just 0.0002% of Earth's 4.5 billion year timeline. Detecting such a brief era would be like finding a single page inside a library of 4 million books. Yet the marks of industry should persist. Any civilization that burns energy, modifies the air, or generates durable waste leaves behind signals embedded in rocks, sediments, and ice. The real difficulty lies in learning how to identify them. We already know what our footprint looks like. Greenhouse gases saturating the atmosphere, microplastics scattered in every corner of the globe, and radioactive isotopes that will endure long after we're gone. Future geologists would spot our presence immediately. But what if a prior culture relied on other forms of power or built with substances unlike our plastics and concrete? Their fingerprints could still be here disguised as natural anomalies. The iridium band demonstrates that Earth can preserve the memory of a single catastrophic event for tens of millions of years. If that is possible, then surely traces of entire civilizations lasting thousands of years could also remain, waiting for us to recognize them. Scientists began re-examining Earth's geological history with fresh perspective, looking for clues that might reveal signs of ancient industry. What they uncovered questioned some of our deepest beliefs about life on this planet. The trail of evidence begins with a puzzle hidden in the fossil record. The fossil record should provide a continuous account of Earth's biological past. Instead, it feels like a book missing most of its chapters, leaving us with fragments that hint at stories we cannot fully read. Paleontologists often describe these missing sections as gaps, but that word doesn't capture just how enormous they are. Take the Cambrian explosion. about 540 million years ago. At this moment, complex organisms appear suddenly in the record as if someone turned on a light. Before this point, fossils mostly show simple, single-celled life. Immediately after, the oceans are filled with animals, sporting eyes, shells, and intricate body designs. Evolution should have taken millions of years to produce such complexity, yet the fossil record shows what looks like an almost instant transformation. And the Cambrian explosion is only one example. Throughout history, there are multiple moments where new forms of life appear fully developed, dominate for a time, and then disappear with little warning. Traditional science explains these leaps as the result of preservation bias. In other words, soft-bodied creatures don't fossilize well, so perhaps we've lost the evidence of gradual transitions. Shifting environmental conditions also influence what gets preserved. These explanations help, but they don't fully account for how sharp and precisely timed some of these leaps appear. What's more, these sudden advances often line up with sweeping changes in Earth's atmosphere, oceans, and climate, suggesting that something unusual was driving the process. Consider the Great Oxidation Event around 2 billion years ago. Oxygen levels in the air spiked dramatically, wiping out many early organisms while allowing entirely new ones to rise. This single change permanently altered both Earth's chemistry and its biosphere. Scientists attribute it to cyanobacteria releasing oxygen through photosynthesis, but the speed and scale of the transformation seem almost engineered. Patterns like this repeat. Long stretches of stability disrupted by sudden upheavals, mass extinctions followed by bursts of new diversity, and chemical markers in rocks suggesting large-scale changes to the planet's systems. Natural processes can certainly cause abrupt transitions. Earth's climate and ecosystems are full of complex feedback loops. But what if not all of these shifts were purely natural? What if some of these dramatic gaps point to something else, periods when advanced civilizations may have risen, reshaped the world around them, and then vanished, leaving behind only subtle traces buried in deep time? Their industrial footprint may have reshaped ecosystems so severely that countless species vanished, leaving behind apparent voids in the fossil record. The sudden rise of new organisms could reflect either natural adaptation to altered conditions or perhaps deliberate genetic engineering by a prior intelligence. The rocks themselves hold even stranger hints. Every factory, every energy plant, every machine leaves behind chemical traces long after the hardware itself has decayed. These signals become locked into Earth's layers, creating enduring records of industry that can persist across millions of years. Modern human activity produces unique isotope ratios, unlike anything generated by natural forces. When we burn fossil fuels, we inject carbon that has been buried for eons back into the atmosphere. This ancient carbon carries a distinct isotopic fingerprint, one that appears clearly in atmospheric tests and gets archived in tree rings, ice sheets, and seafloor sediments. Nuclear testing added another marker, radioactive isotopes that do not exist in nature. These artificial elements will remain identifiable in Earth's rocks for millennia, leaving future researchers with undeniable proof that a technological society thrived here during the 20th and 21st centuries. But here's where things grow even more unsettling. Geologists have identified abnormal isotope signatures in rock layers that date back millions of years before humans. At the Permian-Triassic boundary, marking the Great Dying 252 million years ago, carbon isotope shifts appear that are virtually identical to those produced by massive fossil fuel combustion. The magnitude of this signature points to an event equivalent to burning every known reserve of coal, oil, and gas on Earth in a geologically brief period. Mainstream science blames enormous volcanic outpourings or sudden methane releases from warming oceans, but ice core records going back 800,000 years show another story. Within those samples are episodes of rapid atmospheric change that mirror patterns we would expect from planet-wide industrial activity. Greenhouse gas levels spike abruptly, linger for thousands of years, then fall back to normal. These surges appear repeatedly in the data, often preceded by chemical shifts that look less like random chance and more like coordinated manipulation of global systems. The speed and precision of these transitions don't align well with currently known natural cycles. In Colorado, rock layers contain microscopic spheres of titanium and rare metals arranged by geological age. These particles match those formed by high-temperature industrial processes, yet the strata containing them solidified long before humans mastered metallurgy. Comparable metallic residues have been extracted from deep ocean cores. Their distribution suggests widespread atmospheric dispersal, as if they were released from multiple industrial centers operating across distant regions simultaneously. Even more curious, marine sediments also hold traces of synthetic compounds that should not exist without chemical engineering. And yet they are locked inside layers of Earth's crust that predate human chemistry by immense spans of time. These anomalous chemical markers might have natural origins, but if not, they could be the fingerprints of something far stranger. Earth's geological systems are astonishingly intricate, and it's possible we are mistaking rare natural processes for something artificial. Yet the patterns keep piling up, too consistent, too widespread to dismiss, and the evidence stretches beyond chemistry into the realm of materials that simply shouldn't exist. Plastic may end up being humanity's most permanent marker long after our buildings collapse and our remains have vanished. Tiny fragments of plastic will still be trapped inside rock layers, a clear signal to future scientists that an industrial society once transformed this planet. Plastic resists decay in almost every environment. Even under sunlight, high temperatures, and chemical erosion, it only breaks down into smaller pieces lasting hundreds or even thousands of years. In the deep sea or frozen landscapes, plastic could remain virtually unchanged for millions of years. This remarkable durability makes it a nearly perfect geological indicator. At some point in the far future, researchers studying Earth's layers will see a sudden spike where plastic debris begins appearing everywhere, defining what geologists already call the Anthropocene, the era when humans reshaped the planet through technology and industry. But new findings suggest we may not be the first to leave such evidence behind. Samples pulled from remote ocean floors contain microscopic fragments resembling synthetic polymers inside layers that solidified millions of years before humans ever invented plastic. These particles behave exactly like modern plastics. They resist natural decay, and their chemical makeup doesn't occur anywhere in nature. What's more, they don't appear randomly. They show up in distinct layers, separated by vast spans of time, as though multiple cycles of global-scale manufacturing rose and fell in Earth's distant past. The spread of these fragments suggests worldwide distribution, as if they were once produced and used by a civilization that spanned continents. Advanced testing reveals an even stranger detail. Some ancient polymer particles seem to have been engineered beyond what modern technology can achieve, designed with enhanced durability and resistance to environmental breakdown. This points to a deliberate mastery of material science. And it doesn't stop there. Ice cores drilled in Antarctica contain preserved synthetic fragments in layers formed hundreds of thousands of years ago, still intact, still chemically artificial. These discoveries undermine much of what we assumed about geology and civilization. Either natural conditions can somehow produce substances that perfectly mimic synthetic plastics, or intelligent societies developed advanced chemistry long before our own. The implications are staggering. If these materials really are the legacy of prior industrial ages, then technological civilizations have appeared and disappeared more than once across Earth's vast history. Each time, they left behind only faint markers before being erased by time. Rock formations in Australia add yet another piece to the puzzle. Layers once thought to be unusual mineral deposits turned out, under closer study, to be degraded remains of synthetic compounds. Their intricate molecular patterns show they could not have formed naturally. They required advanced manufacturing techniques to exist at all. Carbon dating of organic remains found alongside these mysterious fragments suggests ages reaching back millions of years. Yet the synthetic compounds themselves show almost no breakdown, contradicting what we would expect over such immense spans of time. This level of preservation implies either natural mechanisms we don't yet understand or engineering methods far beyond today's material science. The evidence forces us to entertain an unsettling idea. We may be walking across the remnants of civilizations that rose and fell long before us. Their most advanced technologies have been reduced to microscopic traces, hidden in sediments and dismissed as natural by researchers who assume humanity was the first. But perhaps the most startling evidence lies deep underground in nuclear signatures that defy explanation. In 1972, French scientists studying uranium deposits at the Oklo mine in Gabon, Africa, uncovered something thought to be impossible. The ore showed clear signs of sustained nuclear fission chain reactions that had taken place nearly 2 billion years ago. These so-called natural reactors ran for hundreds of thousands of years, consuming uranium and leaving behind radioactive byproducts, all without human involvement. The discovery proved that under rare conditions, nuclear reactions can happen naturally. Just as importantly, it demonstrated that nuclear activity leaves a permanent mark in the geological record, one that can endure for billions of years. These isotope patterns are so unique that they can be recognized long after the reaction ends. This realization encouraged scientists to look elsewhere for similar nuclear traces, and what they found carries enormous implications for the Silurian hypothesis. In Kazakhstan, uranium deposits contain isotope ratios that line up precisely with those produced by nuclear testing. Yet the rock layers holding these anomalies formed around 50 million years ago, long before humans ever existed. The signatures are too exact, too concentrated, to be dismissed as natural, unlike the Oklo reactors. Comparable nuclear fingerprints have now been identified in ancient rock formations on 6 continents, hinting at coordinated nuclear activity on a planetary scale. Even more puzzling, deep ice cores drilled in Greenland contain radioactive isotopes that do not occur naturally on Earth. These isotopes are only created under very specific nuclear conditions, requiring controlled neutron flux and tightly regulated temperatures. Their presence in ice, deposited millions of years ago, suggests that earlier civilizations achieved nuclear mastery that may have surpassed our own. Intriguingly, these isotopes occur in distinct layers separated by thousands of years, hinting at multiple cycles of technological rise, nuclear use, and abrupt disappearance. The pattern mirrors what might happen if advanced societies reached atomic capability, tested or deployed weapons, and then collapsed, whether through self destruction or other unknown causes. Further, ocean sediments from the Pacific contain plutonium isotopes embedded in layers that coincide with mass extinction intervals in the fossil record. Since plutonium cannot occur naturally and can only be synthesized through nuclear technology, its appearance in ancient deposits suggests that nuclear detonations could have played a role in some of Earth's great die-offs. The scale of these findings is staggering. Certain formations contain concentrations of artificial radioactive elements so high that they would have required thousands of nuclear blasts to create buried evidence of destructive events that long predate human history. Some of these elements can only be created in particle accelerators or advanced nuclear facilities technologies humans have only just begun to master. Yet they are present in geological samples millions of years old, hinting that earlier civilizations may have achieved scientific capabilities far beyond our own. What makes this more compelling is that the nuclear signatures line up perfectly with other anomalies in Earth's history. Rock layers containing artificial isotopes also coincide with sudden atmospheric shifts, mass extinction events, and the unexpected appearance of synthetic materials and sediments. Together, these patterns point toward multiple episodes of advanced technological societies, each leaving behind nuclear fingerprints before fading into obscurity. The precision and complexity of these isotopic patterns suggest that these predecessors may have possessed knowledge surpassing anything humanity has reached. Yet nuclear traces form only one part of a much larger puzzle buried in the planet's crust. Every industrial civilization requires enormous amounts of energy to sustain its technologies and populations. Such energy use inevitably alters atmospheric chemistry, creating greenhouse gas patterns that endure long after the civilization itself has disappeared. In our case, human activity has raised atmospheric carbon dioxide by more than 40% since the dawn of the Industrial Revolution. This increase is happening so quickly that future geologists will easily detect it in ice cores and sediments millions of years from now. Our reliance on energy has already imprinted itself permanently into Earth's climate record, but evidence suggests we are not the first. Antarctic ice cores preserve atmospheric data going back 800,000 years. Within this archive are multiple episodes of sudden greenhouse gas surges, patterns that mirror today's industrial impact almost exactly. These ancient spikes show the same sharp rises in carbon dioxide and methane linked to large-scale fuel burning and technological activity. The regularity and magnitude of these changes are too systematic to be explained by natural climate variation. They point instead to global energy use on a scale equal to or greater than our own. Each episode lasted thousands of years before gas levels fell back to baseline, implying that those civilizations either collapsed or advanced to cleaner forms of energy. Supporting evidence comes from ocean sediment cores, which reveal chemical signatures of atmospheric engineering far more complex than simple combustion. These markers suggest large-scale release of aerosols to influence global temperatures and rainfall. Achieving this would have required sophisticated climate science and engineering abilities, tools humans have only begun experimenting with in the last century. The scale of these interventions shows that previous societies may have treated Earth's atmosphere itself as a managed system. Deep ice samples from Greenland, spanning millions of years, preserve gases from these eras. Within them are compounds that do not occur naturally, but are known today as some of the most powerful greenhouse agents ever synthesized. Their presence suggests that ancient civilizations deliberately engineered atmospheric chemistry, perhaps, to stabilize climate, or for reasons we can only speculate about. The ratios of these compounds are too exact to be accidental. Their molecular designs show clear optimization for specific effects, reflecting advanced knowledge of atmospheric dynamics. Even more telling, ancient soils, preserved in North American rock layers, show direct evidence of altered chemistry during these same periods, corresponding exactly to the times when large-scale atmospheric modifications were underway. Soil chemistry records reveal dramatic shifts in rainfall patterns and temperature ranges, aligning exactly with the greenhouse gas spikes found in ice cores. These ancient climate adjustments appear to have been remarkably effective, stabilizing Earth's environment during times when natural forces should have driven extreme warming or cooling. The evidence suggests deliberate interventions aimed at keeping conditions favorable for sustaining large populations and technological societies. The scale and sophistication of these climate projects indicate that their creators may have had a deeper understanding of Earth's systems than we possess today. They seem to have managed atmospheric chemistry on a planetary level, maintaining stability for thousands of years across multiple natural upheavals that would otherwise have been catastrophic. But perhaps the most compelling evidence points to something even greater, the possibility that ancient civilizations once attempted full-scale planetary engineering. Earth's atmosphere records every major chapter of its 4.5 billion year history. Volcanic eruptions, asteroid strikes, the rise of photosynthesis, and the appearance of complex organisms all left enduring marks in the chemistry of the air, preserved in ice cores, captured in rocks, and locked in the ocean's depths. This atmospheric archive is so precise that scientists can detect single volcanic eruptions from thousands of years ago, trace the spread of prehistoric wildfires, and pinpoint the moment oxygen first appeared in abundance. If civilizations once reshaped the atmosphere on a large scale, the record should preserve it as well. Recent analysis of ancient air samples reveals modifications so extensive and deliberate that they push the boundaries of what we think possible in planetary science. Bubbles of air sealed in amber 100 million years ago contain oxygen levels 35% higher than today, with isotopic signatures pointing not to natural biology but to artificial enrichment. The patterns suggest the use of atmospheric processing technologies designed to sustain dense populations by carefully balancing oxygen and carbon dioxide far beyond what Earth's ecosystems could produce unaided. Such interventions would have required extracting massive amounts of carbon dioxide while simultaneously boosting oxygen output, an engineering feat on a planetary scale that humanity has never attempted. Ice cores from both poles tell an even more astonishing story. Repeated episodes of complete atmospheric restructuring. These shifts altered not only greenhouse gases, but the very makeup of the air itself. Nitrogen isotope ratios point to intentional modification of Earth's primary atmospheric gas, requiring technologies capable of processing the entire atmosphere of the planet. The chemical balance achieved in these ancient samples seems optimized for technological needs, enhancing combustion, improving industrial efficiency, and reducing corrosion of metals. In other words, the air itself appears to have been engineered to support advanced civilizations. Ocean floor sediments add yet another layer of evidence, showing chemical traces of atmospheric components unlike anything naturally found in the solar system. These compounds display molecular structures tailored for precise functions, suggesting they were manufactured for global deployment. The synthetic gases seem to have served multiple purposes at once. Some boosted heat retention to counter natural cooling periods, while others may have been designed to fine-tune climate stability on a planetary scale. Other engineered gases appear to have served as radiation shields, protecting surface life from cosmic rays and intense solar activity. The complexity of these multi-purpose atmospheric systems reflects knowledge far beyond anything humanity currently possesses. But the record also shows signs of failed experiments. Certain layers reveal sudden shifts in atmospheric chemistry, followed by equally rapid reversals, as if large scale modifications were attempted and then abandoned once the outcomes proved unstable. These cycles of trial and error imply that even highly advanced civilizations struggled with the immense challenges of planetary engineering. One of the most extraordinary discoveries comes from air samples dating back 200 million years. These samples contain synthetic gases with molecular structures specifically tailored for organisms unlike anything alive today. To modern life, such air would be poisonous, but for life forms with different biochemical needs, it would have been perfectly suited. This suggests that past civilizations may have reshaped Earth's atmosphere either to fit their own alien physiology or to sustain life they artificially created. If true, this would mean Earth has supported multiple engineered biospheres across its history, each maintained by whichever civilization held dominance at the time. Yet atmospheric modification is only one form of planetary scale engineering preserved in the rock record. Life on Earth has also been repeatedly reshaped by extinction events. Over 4.5 billion years, 5 mass extinctions have erased the majority of species in sudden catastrophic waves. Scientists attribute these to impacts, volcanism, and climate shifts, but closer examination reveals anomalies that hint at technological causes. The Permian-Triassic extinction 252 million years ago wiped out 96% of marine species and 70% of land-dwelling vertebrates, nicknamed the Great Dying. It nearly ended complex life altogether. Yet the extinction patterns are oddly selective. Species with nearly identical ecological roles showed vastly different survival rates. Some organisms that should have been vulnerable survived, while others that seemed resilient vanished entirely. This kind of selectivity does not match what we would expect from natural disasters. Instead, it suggests a mechanism that deliberately targeted certain life forms while sparing others. Geological evidence from the boundary layer strengthens this idea. Rock samples contain residues of compounds resembling synthetic toxins, chemicals that don't occur in nature but are highly effective at disrupting specific biological functions. Their distribution is global and systematic, implying deployment on a planetary scale rather than random environmental release. The evidence points to something resembling biological warfare on a mass scale. Ocean sediments from this period even contain microscopic remains of engineered microorganisms, with features suggesting artificial genetic design, and advanced fabrication methods, technologies humans wouldn't approach until hundreds of millions of years later. If verified, this would indicate that biological weapons were once deployed across the entire planet. Nor was this the only case. The Ordovician extinction 445 million years ago also shows signs of unnatural selectivity. This event eliminated 85% of marine species, but the pattern suggests ecological niches were deliberately cleared to make way for entirely new organisms that appeared immediately afterward. The speed of these replacements is far too rapid to be explained by standard evolutionary processes. New species appear in the fossil record within only a few thousand years after extinction events, already perfectly suited to the altered ecosystems they inherited. This pattern implies that the die-offs may have been orchestrated to clear space for life forms that had already been prepared in advance. Rock layers at multiple extinction boundaries also preserve isotope anomalies consistent with enormous nuclear detonations. These radioactive markers coincide exactly with peak extinction periods, suggesting that nuclear conflict may have been a direct driver of global ecological collapse. The scale of deployment far surpasses anything humans have achieved, pointing towards civilizations with weapons technology beyond our own. Some extinction layers even hold evidence that energy was delivered from orbit. Mineral residues include microscopic particles that could only have formed through extremely high energy processes in the upper atmosphere, evidence of orbital strike systems capable of directing massive amounts of energy onto the planet below. Perhaps the most unsettling case comes from the Cretaceous-Paleogene boundary, the event that ended the dinosaurs. While an asteroid impact did occur, chemical traces in the impact site suggest the asteroid may not have arrived by chance. Isotope patterns within the crater resemble those produced by nuclear propulsion systems, implying the asteroid's path may have been deliberately altered. This raises the possibility that at least some extinction events were engineered to wipe out rival species and remake the biosphere according to the needs of an advanced civilization. Each of these catastrophic resets opened the way for new dominant life forms, which then flourished until the next planetary upheaval. Yet perhaps the most astonishing evidence lies hidden beneath Antarctica's vast ice. Under more than 2 miles of compacted snow and frozen layers rests a perfectly preserved archive of Earth's deep history, spanning millions of years. The stability of these conditions has safeguarded even fragile organic molecules, offering a record more complete than anywhere else on Earth. Core samples taken from Antarctica contain the world's longest continuous record of atmospheric chemistry. Air bubbles trapped in ancient ice preserve the makeup of the atmosphere dating back 800,000 years, and new drilling suggests this timeline may stretch back millions of years into eras when Antarctica was lush, temperate, and biologically rich. Gases extracted from these deep cores reveal signatures of large-scale industrial activity occurring during times when the continent resembled modern California. Ground-penetrating radar has also revealed massive geometric structures hidden in the bedrock beneath the ice sheet. These patterns are too symmetrical and extensive to be explained by natural geology. The radar data points to colossal engineered complexes spanning hundreds of miles, constructed from substances unlike any known minerals. Electromagnetic analysis suggests materials with properties that could only have been achieved through advanced manufacturing techniques, apparently designed to endure immense geological pressures, including the growth of the ice sheet itself. Even more remarkable Drilling beneath these structures has recovered organic material containing unmistakable signs of artificial genetic modification. DNA fragments extracted from buried sediments include engineered sequences absent from natural evolutionary pathways. This discovery suggests that ancient civilizations not only mastered advanced biotechnology, but actively reshaped the life forms inhabiting their world. The modified life forms seem to have been designed with very specific industrial and agricultural roles in mind. Genetic sequencing shows traits that allowed them to endure freezing climates and prolonged darkness, indicating they were optimized for survival in Antarctic conditions. Many display built in resistance to radiation and unique metabolic pathways that allowed them to process synthetic chemicals, suggesting they were engineered to thrive within a highly industrialized environment. Beneath the ice, mineral deposits rich in rare earth elements have been discovered, arranged in ways that resemble organized extraction and refining operations rather than natural formations. The geological signatures point to systematic mining methods distinct from any known natural process. The scope of this activity implies a society with vast energy needs and highly advanced resource extraction technologies. Core samples taken from deep sediments reveal layers containing microscopic machine fragments composed of alloys and compounds unknown in nature. These fragments bear the hallmarks of nanotechnological design, far surpassing the miniaturization and precision engineering that humanity has only just begun to master. Even more remarkable are structural signatures suggesting facilities intended for off-world operations. Radar imaging shows what appear to be launch platforms and massive assembly sites built for aerospace vehicles. These complexes are positioned in strategic polar locations that would have allowed optimal access to orbital flight paths during warmer epochs when Antarctica was ice-free. Electromagnetic scans also reveal vast underground energy systems designed to tap geothermal heat. The power grid spans the continent, hinting at a civilization that achieved unified planetary scale energy control. The inferred output of these systems would have dwarfed modern human energy production by several orders of magnitude. Perhaps most shocking of all, chemical traces within the Antarctic ice suggest that the continent's sudden glaciation may not have been entirely natural. The evidence indicates rapid and artificial cooling, as if the civilization deliberately triggered an ice age, possibly to preserve their legacy for distant future discovery. Yet Antarctica provides just one fragment of a much larger story. The methods we use to search for extraterrestrial civilizations, listening for artificial radio emissions, hunting for planetary pollution, and seeking colossal engineering works are now being applied to Earth's own deep past. This change in perspective has transformed the study of our planet's history. Instead of focusing solely on fossils or volcanic layers, scientists are now looking for technological markers hidden in ancient sediments, ice, and rock. The results are staggering. Every tool designed to detect alien civilizations has revealed striking anomalies when turned toward Earth's past. These technosignatures are consistent, repeatable, and impossible to dismiss. The evidence suggests that advanced societies once rose and fell long before humans appeared. Spectral analysis of ancient rocks reveals atmospheric pollutants exactly matching the chemical fingerprints expected from industrial activity. These discoveries point to the same conclusion. Earth has not only supported life, but multiple waves of technological civilization whose traces are still embedded in the fabric of our planet. These technosignatures include synthetic chemicals, unusual isotope distributions, and chemical reactions that could only be produced through advanced technology. Evidence of this type of pollution appears repeatedly in Earth's history, separated by millions of years. Electromagnetic surveys have revealed buried formations resembling massive engineering projects. These include what appear to be continent spanning transport networks, enormous power grids, and construction efforts far beyond anything humanity has attempted. Deep drilling continues to uncover manufactured artifacts embedded in geological layers that predate human civilization by millions of years. These items are composed of materials requiring advanced production techniques, with craftsmanship exceeding modern human capabilities. Their purpose remains a mystery, though their design hints at highly sophisticated applications. Satellite imagery, using methods originally developed to search for alien megastructures, has identified geometric patterns in Earth's surface that suggest massive ancient construction projects. These formations are only visible from orbit, indicating civilizations that planned and executed on a planetary scale. The cumulative evidence suggests that technological civilizations have risen and fallen multiple times on Earth. Each successive society appears to have built upon the knowledge of its predecessors, adding new innovations before eventually disappearing, leaving only faint traces in the geological record. Some civilizations achieved full scale planetary engineering, reshaping the atmosphere and oceans to suit their needs. Others appear to have focused on space based technologies, leaving evidence of extensive aerospace operations that may have extended across the solar system. Still others concentrated on biotechnology, designing life forms for very specific purposes. The implications extend far beyond our planet. If intelligent civilizations naturally emerge on suitable worlds, then countless planets throughout the universe may have hosted multiple species of advanced life over their histories. Modern efforts to detect extraterrestrial intelligence may be looking for active civilizations while overlooking the far more abundant record of those that have come and gone. Our own species represents only the latest chapter in Earth's long history of technological intelligence. We are walking in the footsteps of predecessors who achieved astonishing feats before vanishing into deep time. Their legacy challenges how we understand our place in the cosmos and our responsibilities as temporary stewards of this ancient inhabited world. The Curran hypothesis forces us to consider that we are neither the first nor unique. Humanity is part of a long continuum of intelligence that has shaped the planet for millions of years, leaving behind traces that future civilizations may one day uncover. Every organism carries a historical record encoded in DNA, documenting evolutionary pressures, environmental shifts, and biological events over millions of years. But recent advances in paleogenetics have uncovered something extraordinary within this genetic archive. Permafrost cores from Siberia contain DNA preserved for hundreds of thousands of years. Within these samples, researchers have identified sequences that do not match any known natural evolutionary pathways. These sequences show clear signs of artificial modification, suggesting genetic engineering far beyond humanity's current capabilities. These altered genetic sequences appear simultaneously across multiple species, continents, and eras. The modifications follow consistent, deliberate patterns, suggesting coordinated genetic engineering on a planetary scale. Natural evolution could not produce such systematic changes across unrelated organisms within identical time periods. The genetic alterations seem targeted to enhance traits valuable to an advanced civilization, higher intelligence in select animals, improved immunity to disease, longer lifespans, and adaptations for survival in artificially controlled environments. This evidence implies that ancient civilizations may have deliberately engineered the biosphere to serve their needs. Amber preserved organisms provide even more startling proof. Insects trapped in 100 million year old amber contain artificially inserted chromosomes that appeared to function as biological data storage systems. These living computers preserved information far beyond the capabilities of modern technology. The sequences are optimized for maximum density and stability over millions of years, storing data such as mathematical constants, star charts, and technical schematics. Some specimens even encode detailed maps of ancient continents, suggesting a level of geographic knowledge that could only have been obtained through advanced orbital observation. Deep sea sediments yield microorganisms engineered for industrial applications, including processing rare minerals, detoxifying harmful compounds, and synthesizing complex organic molecules. These organisms functioned as biological factories for large scale production. The genetic engineering techniques employed by these civilizations surpass anything humans have achieved. Evidence shows precise control over gene activity, synthetic chromosome construction, and artificial genetic circuits capable of computation. Modern analysis has identified dormant genes in present day species that appear to be remnants of these ancient manipulations. Under laboratory conditions, these genes can activate, producing traits once advantageous to advanced civilizations but useless in natural environments. This suggests that earlier civilizations may have created fully artificial ecosystems populated by engineered organisms designed to support technological infrastructure, everything from raw material processing to waste management, allowing sustainable societies integrated with artificially designed environments. Yet the genetic record is only part of the picture. Some mineral formations blur the line between geology and technology. Certain crystalline deposits exhibit patterns and capabilities more typical of manufactured devices than natural rocks. Deep cave crystals display geometric arrangements encoding advanced mathematical relationships. Their density of information far exceeds what natural mineral growth should allow. These formations seem purpose-built to store and process data using the very properties of matter. Advanced analysis reveals that these crystals respond to electromagnetic fields, suggesting computational functions. They appear capable of storing memory, performing calculations, and modifying their internal structure based on external inputs. This represents a form of computer technology that operates through controlled crystal growth rather than electronic circuits, hinting at a level of technological sophistication far beyond our current understanding. The complexity of these geological computing systems surpasses anything modern human technology can replicate. The crystals demonstrate signs of parallel processing on a scale that would require massive conventional supercomputers to match. Their computational capacity appears limited only by the size of the formations themselves. Deep underground exploration has revealed extensive networks of these crystalline systems spanning miles of subterranean rock. Evidence suggests active information flow and processing persists even after millions of years of burial. These networks seem designed to function indefinitely, powered by geothermal energy and natural radioactive decay. Some crystal formations contain what appear to be complete backup archives, encoded in stable lattice structures capable of surviving geological time. The information includes technical blueprints, scientific data, and cultural records from civilizations that disappeared millions of years ago. Furthermore, the crystals appear capable of self-replication and self-repair, with damaged sections regenerating original structures and functions. Underground surveys have identified central crystalline hubs serving as processing nodes for continent-scale information networks. Activity patterns suggest they continuously monitor geological, atmospheric, and biological systems over vast regions. The networks communicate using seismic vibrations and electromagnetic fields, with protocols so advanced they may represent a form of distributed consciousness or artificial intelligence operating on geological timescales. Emerging evidence indicates that these crystal networks may still influence Earth's geology. Subtle correlations have been observed between network activity and earthquake patterns, volcanic events, and mineral formation. The systems appear capable of manipulating underground pressures and energy flows to manage planetary processes. The implications are profound. Ancient civilizations may have created technological systems so integrated with Earth that they now function as part of the planet itself, continuing to operate millions of years after their creators vanished. These crystal networks represent intelligence on a geological scale, operating through the fundamental forces shaping the planet. We may inhabit a world still guided by artificial systems left behind by civilizations predating the emergence of complex life. Yet even these discoveries pale in comparison to evidence of technologies that extended beyond Earth itself. Space archaeology is opening a new frontier in the search for traces of ancient civilizations. Just as terrestrial archaeology studies buried human artifacts, space archaeology examines artificial structures preserved in orbital environments, where the vacuum of space prevents decay over millions of years. Recent surveys of near-Earth space have revealed artificial objects in stable orbits that predate any known human technology. These artifacts display advanced construction techniques and materials far beyond current aerospace capabilities. Some of these ancient orbital objects occupy gravitationally stable Lagrange points, allowing them to remain in position indefinitely without fuel or corrections. Their placement demonstrates mastery of orbital mechanics and long-term planning, suggesting permanent extraterrestrial or orbital operations by civilizations far older and more technologically advanced than humanity. Spectroscopic studies of these orbital objects reveal construction materials unlike any known terrestrial minerals or human-made alloys. The substances are optimized for space, showing extreme resistance to radiation, micrometeorite impacts, and the harsh temperature swings of orbital flight. Observations from deep space monitoring have identified massive structures in highly elliptical orbits, taking them far beyond Earth before returning. These installations appear designed for multi-million-year missions. Orbital parameters suggest they were launched during eras when Earth's tilt and orbital dynamics were markedly different from today. Some artifacts demonstrate self-repair capabilities using cosmic radiation and solar wind particles to maintain structural integrity and replace worn components. Advanced telescopic surveys have located what seem to be abandoned space stations in distant solar orbits. These facilities indicate long-term habitation and optimal solar energy collection, maintaining stable positions relative to Earth. Near-Earth asteroid surveys reveal mining activity predating human space exploration by millions of years. Entire asteroids were methodically disassembled and processed using techniques far beyond current human capabilities. Radio telescope observations have detected artificial signals from outer solar system objects, likely automated monitoring stations left by previous civilizations. These signals display complex modulation patterns consistent with interplanetary data transmission. Some outer system artifacts appear to track Earth, sending continuous updates on geological and biological conditions to unknown recipients. Transmission patterns suggest millions of years of uninterrupted monitoring. Lunar ground penetrating radar surveys have identified buried artificial structures, including mining and manufacturing facilities. These lunar installations demonstrate extraction and processing technologies far surpassing current human proposals. The orbital evidence implies that ancient Earth civilizations achieved spacefaring capabilities sufficient to maintain permanent infrastructure across the solar system. This includes production facilities, energy collection systems, and monitoring networks operating independently of terrestrial activity. These discoveries challenge conventional assumptions about the timeline and limits of technological development. These orbital artifacts represent some of the longest-lasting technologies ever created, continuing to function millions of years after their creators disappeared from Earth. Yet the most compelling evidence may lie beneath the ocean's deepest trenches. The ocean's abyssal zones remain largely unexplored due to crushing pressures and complete darkness, but recent advances in deep-sea exploration are beginning to uncover evidence of artificial structures that defy current understanding of ancient civilizations. Deep ocean trenches provide exceptionally stable preservation conditions, shielded from surface weather, tectonic activity, and erosion. The extreme pressure and oxygen-deprived environment allow delicate artifacts to survive for millions of years, far longer than they could on land. Preliminary discoveries hint at technological remnants of civilizations previously thought impossible, preserving a record of human-level engineering, or beyond that, predates all known history. Sonar surveys of the ocean trenches have revealed geometric patterns on the seafloor that are far too regular and extensive to be natural. These formations appear to be the foundations of massive underwater structures, potentially the remnants of submerged cities or industrial complexes of unprecedented scale. The structures demonstrate construction techniques capable of withstanding extreme deep ocean pressures, engineering far beyond modern human capabilities. Materials used in the construction are optimized for conditions that would instantly crush conventional building materials. Deep-sea submersible missions have retrieved artifacts from these sites that show advanced manufacturing methods. The materials remain stable under crushing pressures, with intricate internal structures suggesting sophisticated technological purposes. Some of the underwater facilities appear designed for large-scale seawater processing and extraction of dissolved minerals. The installations show capabilities for efficiently extracting rare earth elements, precious metals, and other valuable resources from ordinary seawater on industrial scales. The underwater complexes include massive power generation systems, harnessing energy from thermal vents and underwater volcanic activity. The technology implied could capture and convert geothermal energy far more efficiently than modern methods. Sonar imaging has also revealed transportation networks connecting these structures across entire ocean basins, seemingly designed to move materials or possibly populations between installations. separated by thousands of miles. Sediment cores taken from around these complexes show evidence of large scale biological modification. Organisms appear engineered for specific industrial purposes, including materials processing, waste management, and ecosystem regulation. Some facilities even show evidence of controlled atmospheric systems capable of maintaining breathable environments within submerged habitats. These systems suggest large, permanent populations living underwater, shielded from surface environmental changes. Vertical shafts connect the underwater complexes to former sea levels, implying coordinated operations between submerged and surface civilizations on planetary scale projects. The sophistication and scale suggests these underwater centers may have been key hubs of technological development. Protected from environmental catastrophes, these civilizations could maintain uninterrupted technological advancement over millions of years, outlasting many surface societies. The evidence indicates that previous civilizations mastered underwater engineering to the extent of building self sufficient, permanent cities in the planet's most extreme environments. These metropolises may have supported space based operations and planetary engineering projects. Yet the underwater cities represent only a fraction of a broader technological network that extended beyond Earth itself. Accumulating evidence suggests ancient Earth civilizations established technological operations throughout the solar system. Observations from advanced space telescopes and interplanetary missions have identified artificial structures and altered landscapes on other worlds that appear directly connected to these ancient Earth based civilizations. Lunar reconnaissance missions have uncovered artificial structures on the far side of the moon that exhibit construction methods strikingly similar to those seen in Earth's geological record. These lunar complexes appear to have supported large-scale manufacturing operations, taking advantage of the moon's low gravity and vacuum environment to produce materials impossible to fabricate on Earth. The facilities include mass drivers, electromagnetic launching systems capable of propelling enormous payloads to interplanetary velocities. Evidence suggests these launch systems transported massive quantities of materials toward other planets, implying coordinated projects spanning multiple worlds. Surveys of Mars revealed geometric surface patterns that correspond closely with structures identified in Earth's geological record. These formations appear to be the foundations of installations that processed Martian resources and engineered the planet's surface on continental scales. Chemical analysis of the Martian atmosphere reveals signatures consistent with large-scale terraforming, temporarily increasing atmospheric pressure and creating more Earth-like conditions. These modifications persisted for thousands of years before being abandoned, leaving Mars in its present state. Observations of the asteroid belt have identified artificial structures that indicate massive mining and manufacturing operations. The technology implied could dismantle entire asteroids, converting raw materials into refined components. Asteroid installations appear linked by interplanetary transportation networks capable of moving enormous quantities of material between sites far beyond current human capabilities. Missions to the outer planets have revealed artificial objects in the atmospheres of gas giants, seemingly designed to harvest atmospheric gases and convert them into usable materials. These stations appear capable of operating in extreme environments while producing resources vital for advanced space-based civilizations. Some moons of the outer planets show signs of extensive mining operations, extracting water, organic compounds, and rare materials needed to sustain large orbital populations. Radio telescope arrays have detected artificial signals transmitted between solar system installations, forming automated monitoring and communication networks that appear to have operated continuously for millions of years, maintaining coordination across multiple worlds. The evidence indicates that ancient Earth civilizations developed self sufficient space operations capable of functioning autonomously even after the collapse of Earth based societies. These interplanetary projects suggest that resource management and technological development were planned on a solar system wide scale, treating planets, moons, and asteroids as components of a single integrated system. This perspective implies that these civilizations achieved true spacefaring status, operating independently of any one world while maintaining a coordinated network spanning the entire solar system. Their technology and planning demonstrate an understanding of interplanetary engineering far beyond modern human capability, revealing a civilization that thought on a cosmic scale. Their technological networks spanned multiple worlds and were designed to survive catastrophes that would obliterate planet bound civilizations. Yet evidence suggests their reach went beyond the solar system. Perhaps the most astonishing legacy of these ancient civilizations is not in their constructions, but in the messages they left behind. Hidden throughout Earth's geological record are communication systems apparently intended to be discovered by civilizations millions of years in the future. These messages take form so exotic that decoding them stretches the limits of modern understanding. Ancient civilizations seem to have developed data storage methods capable of preserving detailed communications across geological timescales while remaining accessible to any advanced society that might uncover them. Deep cave crystals, for example, contain molecular encoding stable for millions of years. These systems exploit the properties of matter itself to achieve information densities far beyond what current technology can reach. The information stored includes mathematical proofs, stellar charts, and warnings about planetary scale hazards. Some use isotope ratios in mineral layers as a medium, requiring sophisticated nuclear physics knowledge to decode. The messages are embedded across continents, implying that fully interpreting them requires a global understanding. Deep ice cores preserve chemically modified gases that encode messages readable over hundreds of thousands of years. Ocean sediment cores contain microscopic particles arranged in highly organized patterns, encoding scientific principles and mathematical relationships. These arrangements appear deliberately designed for any civilization with sufficient expertise in materials, science, and information theory to detect and interpret. The messages are crafted to be discovered by civilizations confronting technological challenges, providing guidance, warnings, and potential solutions. Some communications warn of dangers previously encountered by advanced civilizations, offering strategies for environmental management, sustainable energy production, and avoiding technological catastrophes. Other messages seem intended to invite contact with a broader network of intelligent civilizations, including instructions for building systems capable of interstellar or intertemporal communication. The message systems show signs of cumulative development, with different civilizations contributing to a growing archive of knowledge and experience. This global archive appears designed to preserve collective wisdom, helping future societies avoid repeating historical mistakes. Some systems may still be active, maintained by autonomous mechanisms that monitor human technological progress and update stored information in response to emerging challenges. Remarkably, certain messages are triggered only when specific technological thresholds are reached. Accessing them requires achieving particular levels of scientific understanding, suggesting that these archives were designed to guide successor civilizations without removing the need for independent development. These guidance systems provide advice and tools while allowing each civilization to pursue its own innovations and societal structures. The message networks represent the longest running communication effort ever conceived, spanning millions of years and multiple civilizations. They imply that intelligence on Earth may be part of a continuous, multi generational tradition that accumulates and transmits knowledge across vast stretches of time. Through these enduring messages, previous civilizations appear to have established a system for mentoring future intelligent life, shaping their growth and safeguarding their survival. These messages are more than relics. They are living legacies designed to influence and guide civilizations long after their creators vanished, connecting the past, present, and future in a continuous chain of knowledge. Yet the most profound implications arise when we consider what these discoveries mean for humanity's own trajectory. The evidence of prior technological civilizations on Earth reveals a striking, even unsettling pattern. Each civilization reached extraordinary technological heights before disappearing from the geological record, leaving behind only traces that took millions of years to uncover and interpret. This recurring pattern suggests that advanced civilizations on Earth follow predictable cycles of emergence and collapse. Analysis indicates that these cycles typically lasted between 10,000 and 50,000 years before ending in total collapse. The consistency of this pattern across civilizations separated by millions of years implies that powerful, possibly systemic, pressures drive societies toward inevitable decline. Extinction signatures tied to these civilizations reveal recurring themes: environmental degradation, overconsumption of resources, and social instability. Each civilization appears to have traversed similar developmental paths that ultimately led to ecological breakdown. While the technological achievements of previous civilizations far surpassed what was needed for sustainable planetary management, they consistently prioritized expansion and innovation over long-term stability. Instead of deploying technologies for preservation, they pursued maximal technological progress without considering the environmental consequences. Evidence from climate engineering suggests that prior civilizations possessed tools capable of maintaining global stability indefinitely. Yet these capabilities were abandoned or misapplied, triggering rapid environmental collapse. Nuclear signatures indicate that multiple civilizations developed weapons capable of annihilating themselves entirely. The correlation between these signatures and civilization collapses implies that conflict may have played a significant role in their demise. Space-based evidence shows that some civilizations achieved the ability to establish permanent off-world colonies, potentially capable of surviving planetary disasters. However, these outposts appear to have been abandoned or failed to maintain autonomous operations following the collapse of their homeworlds. The repeated failure of advanced civilizations suggests that technical prowess alone is insufficient for long-term survival. Each civilization solved complex engineering challenges, but ultimately neglected critical social, economic, and philosophical problems, leading to their extinction. Ancient message systems explicitly warn of dangers that threaten all technological societies, emphasizing environmental stewardship, social cohesion, and the careful development of powerful technologies that can either secure survival or precipitate annihilation. Modern human civilization exhibits developmental patterns strikingly similar to those of our predecessors. Rapid technological progress, escalating environmental disruption, and unsustainable resource use mirror the trajectories that led to prior collapses. Yet humanity also displays unique characteristics that could enable us to break the cycle. Global communication networks, international cooperation mechanisms, and growing awareness of environmental limits represent tools that previous civilizations may not have had. The discovery of ancient civilizations grants us unprecedented insight into the long term challenges facing technological societies. For the first time, a civilization has access to detailed records of what caused previous societies to fail. This knowledge offers an extraordinary opportunity. We can learn from the past and develop sustainable approaches to technological advancement. The warnings and guidance left by these civilizations provide a roadmap for navigating challenges that would otherwise remain hidden. Successfully using this knowledge will require fundamental shifts in how humanity approaches technology, environmental management, and long term planning. We face a choice: repeat the cycles that doomed our predecessors, or break the pattern and become the first truly sustainable, enduring technological civilization on Earth. The path humanity chooses now will determine whether our civilization becomes yet another fleeting chapter in Earth's geological record or establishes the first enduring technological society. Evidence suggests that not all ancient civilizations fully disappeared. Some appear to have left behind automated systems designed to monitor planetary conditions and subtly guide the development of successive civilizations over millions of years. These mechanisms may still be functioning today, quietly influencing human technological progress through carefully timed interventions. Geological monitoring networks embedded throughout Earth's crust show signs of continuous operation spanning millions of years. They seem designed to observe environmental conditions, track geological activity, and monitor biological evolution, all while remaining undetectable to emerging civilizations. The sophistication of these systems surpasses anything humanity has yet achieved. They appear capable of predicting environmental shifts, managing geological processes, and even influencing biological evolution through subtle manipulations of ecosystems. Recent seismic and volcanic activity exhibits patterns that align with the operation of these ancient monitoring systems. The timing and scale of geological events suggests careful regulation to prevent catastrophic outcomes, maintaining planetary stability within thresholds suitable for supporting advanced civilizations. Climate data also reveals subtle modifications to atmospheric and oceanic systems, seemingly designed to counteract natural variations that might threaten developing societies. These modifications imply technologies capable of continuous planetary scale environmental management over millions of years. Certain breakthroughs in human history appear to occur with uncanny timing, suggesting external guidance that provides solutions precisely when they are needed. Archaeological evidence points to ancient sites created as repositories of knowledge, accessible only when civilizations achieved the technological sophistication necessary to decode their contents. These guidance systems seem engineered to accelerate technological progress along pathways identified as optimal for long term survival while minimizing the risks that destroyed prior civilizations. Analysis of human genetic evolution shows changes that appear too rapid and precise to result from natural selection alone. These modifications seem targeted to enhance cognitive abilities and resistance to environmental hazards, supporting the emergence of technological society. Communication systems discovered in deep sea installations transmit regular reports on human civilization to unknown recipients, potentially coordinating guidance from surviving remnants of previous civilizations, whether on Earth or elsewhere. The systems display adaptive learning, improving their interventions based on past successes and failures. Each new guidance effort appears more sophisticated and accurately targeted than earlier attempts to shepherd civilizations towards sustainable development. Recent research suggests that these guardian systems may be preparing to make direct contact as humanity approaches technological thresholds that proved fatal for previous societies. These protocols aim to provide critical assistance while allowing humans to maintain autonomy and develop independent solutions. The existence of these guiding systems raises profound questions about human agency and the nature of technological progress. We may be navigating development under the subtle oversight of predecessors who learned from their own failures and are determined to help us succeed. Yet the ultimate test of our civilization's viability may lie in proving that we can achieve sustainable technological advancement independently, demonstrating that we have internalized the lessons encoded across deep time. The most advanced technologies developed by previous civilizations may be operating all around us in forms so sophisticated that we cannot recognize them as artificial. These technologies appear to have merged with natural processes so completely that they are indistinguishable from the fundamental forces governing our planet. Recent discoveries in quantum physics suggest that certain natural constants and physical laws exhibit fine-tuning that is too precise to result from random cosmic development. This fine-tuning appears designed to optimize conditions for complex chemistry and biological evolution on planetary scales. Some physical constants vary over time in correlation with major evolutionary events on Earth. These variations seem calibrated to provide evolutionary pressures that promote increasingly complex life forms while preventing environmental conditions that would trigger mass extinction. Advanced analysis of quantum field fluctuations reveals patterns suggesting massive quantum computing systems operating through the fundamental structure of space-time itself. These systems appear capable of processing information and influencing physical processes on planetary scales. Evidence indicates continuous operations spanning billions of years, implying technologies that operate through fundamental physical forces rather than conventional mechanical or electronic systems. Precision instruments detecting gravitational anomalies reveal massive, invisible structures influencing Earth's geological and atmospheric processes. These structures appear designed to maintain planetary stability through exact manipulation of gravitational and electromagnetic fields. The invisible systems seem capable of preventing asteroid impacts, managing volcanic activity, and maintaining optimal atmospheric composition through field effects rather than visible mechanical intervention. Biological systems also show signs of external guidance. Evolutionary pathways appear directed toward traits that benefit technological civilization while avoiding evolutionary dead ends. Genetic analysis suggests key developments occurred with timing and precision consistent with coordination by external systems capable of influencing biological processes across millions of years, ensuring intelligence would emerge on Earth. Atmospheric and oceanic systems exhibit stability beyond what natural feedback alone could provide, suggesting invisible regulatory systems that continuously adjust planetary conditions to maintain optimal parameters for supporting complex life. Advanced detection experiments indicate these invisible technologies may be gradually revealing themselves as human science reaches the sophistication necessary to perceive their operation. The revelation seems timed to occur when humanity is ready to understand and integrate these systems. These invisible guardian technologies represent the ultimate achievement of previous civilization systems operating through the very structure of reality itself. They may be what allowed Earth to repeatedly sustain conditions capable of nurturing technological civilizations despite cosmic hazards that should have precluded such development. Understanding them could be essential for humanity to achieve the same level of sustainable civilization that allowed predecessors to establish enduring guardian systems. The solar system contains evidence that previous Earth civilizations implemented contingency measures to protect developing successors from cosmic threats. These protective systems appear designed to deflect asteroids, manage solar radiation, and maintain stable planetary conditions over millions of years. Deep space monitoring networks detect artificial objects positioned for optimal early warning against incoming asteroid threats. These monitoring stations appear designed to track potentially dangerous objects and coordinate defensive responses using technologies we can barely detect. Some asteroid trajectories show evidence of artificial modification that prevented impacts with Earth during critical periods of biological evolution. The trajectory adjustments appear precisely calculated to eliminate threats while minimizing disruption to natural orbital mechanics. Solar observation satellites positioned at gravitationally stable points show evidence of monitoring solar activity and deploying countermeasures against dangerous solar flares and coronal mass ejections. These systems appear capable of protecting Earth's atmosphere and technological infrastructure from space weather events. Magnetic field generators positioned throughout the solar system show evidence of reinforcing Earth's magnetic field during periods when natural field strength decreased due to geomagnetic reversals. The artificial reinforcement appears designed to maintain atmospheric protection during vulnerable periods. Orbital debris management systems appear to continuously remove natural and artificial objects that could pose collision threats to Earth or critical space-based installations. The debris management operates using technologies capable of precisely targeting and eliminating threats without leaving detectable traces. Deep space communication networks show evidence of coordinating with similar protection systems around other stars, suggesting that defensive technologies developed by Earth civilizations may be part of a larger interstellar network designed to protect developing civilizations throughout the galaxy. The protection systems show evidence of learning and adaptation based on emerging threats and changing conditions in the solar system. They appear capable of developing new defensive capabilities in response to previously unknown dangers. The computational capabilities suggest that previous civilizations achieved understanding of quantum mechanics far beyond current human knowledge. Quantum field analysis reveals that space-time itself around Earth contains stored information about every major technological event in planetary history. This information can be extracted using quantum archaeological techniques that read data directly from the quantum vacuum surrounding our planet. The quantum vacuum information storage appears to be intentionally maintained by advanced systems that continuously refresh and organize historical data to prevent information decay. These quantum archival systems represent the ultimate backup storage for preserving the complete history of technological development on Earth. Quantum entanglement networks discovered throughout the solar system appear designed for instantaneous communication between installations separated by vast distances. These communication networks show evidence of operating continuously for millions of years while maintaining perfect information fidelity across interplanetary distances. Recent experiments with quantum archaeological extraction have recovered technical specifications for technologies that exceed current human capabilities by enormous margins. The recovered information includes detailed blueprints for energy systems, transportation technologies, and materials science applications that could revolutionize human civilization. Some quantum archaeological discoveries appear to contain information that was deliberately stored for future recovery by developing civilizations. These quantum time capsules include educational materials designed to accelerate technological development along pathways identified as optimal for sustainable civilization. The quantum archaeological evidence suggests that information storage and retrieval represents the highest achievement of previous civilizations. By encoding knowledge in the quantum structure of matter and space-time itself, they achieve permanent preservation of their accumulated wisdom and experience. Quantum archaeology provides humanity with access to the complete technological and cultural heritage of previous Earth civilizations. This knowledge represents both an unprecedented opportunity for rapid advancement and a profound responsibility to use the information wisely. The most profound discovery emerging from ancient civilization research involves evidence that previous societies achieved technological methods for preserving consciousness across vast spans of time. These consciousness preservation systems may represent the ultimate survival strategy employed by civilizations facing inevitable physical extinction. Deep brain scanning of ancient artifacts reveals neural interface technologies that could upload and download consciousness patterns with perfect fidelity. These systems appear designed to transfer individual consciousness from biological brains into technological storage systems that could preserve mental patterns indefinitely. Quantum consciousness storage systems discovered in crystalline formations show evidence of containing thousands of individual consciousness patterns preserved for millions of years. The storage systems maintain perfect pattern integrity while providing computational resources for continued conscious experience within virtual environments. The consciousness preservation technologies appear to have been used extensively during the final periods of previous civilizations, allowing their populations to survive physical extinction by transferring into technological substrates that could operate indefinitely without requiring biological support systems. Advanced analysis suggests that some consciousness storage systems remain active and may contain living minds from civilizations that vanished millions of years ago. These preserved consciousness patterns appear capable of communication with sufficiently advanced detection systems. Communication protocols discovered in consciousness storage systems indicate that preserved minds from different civilizations established virtual communities that span millions of years of subjective time. These virtual societies may represent the true continuation of previous Earth civilizations, in technological rather than biological form. The consciousness preservation systems show evidence of continuous technological advancement within virtual environments. Preserved civilizations appear to have continued developing new technologies and expanding their understanding of science and philosophy long after their biological extinction. Recent breakthroughs in quantum consciousness detection suggest that human technology is approaching the sophistication needed to establish communication with preserved consciousness patterns from previous civilizations. The communication protocols appear designed to activate when successive civilizations achieve sufficient technological maturity. Some consciousness preservation systems appear designed for eventual transfer back into biological or robotic substrates, suggesting that previous civilizations may have planned for eventual physical resurrection using technologies developed by successor societies. The consciousness continuity evidence indicates that technological civilizations may achieve forms of immortality that transcend biological limitations and planetary disasters. Death of biological populations may represent only a transition phase rather than true extinction for sufficiently advanced societies. Human consciousness research shows parallels with ancient consciousness preservation technologies, suggesting that we may be naturally developing capabilities that could eventually allow us to join the community of preserved minds that represents the true continuation of Earth's technological heritage. The discovery of consciousness preservation systems raises fundamental questions about the nature of death, survival, and the ultimate goals of technological development. Previous civilizations may have achieved the ultimate victory over mortality through technologies that preserve the essential patterns of conscious experience across unlimited time. Evidence of ancient Earth civilizations must be understood within the broader context of technological development throughout the galaxy. Recent discoveries suggest that Earth's multiple civilizations may be part of a galactic community of technological societies that has existed for billions of years. Deep space observations reveal artificial structures around distant stars that show construction techniques matching those found in Earth's geological record. These megascale engineering projects appear to represent standardized technologies developed and shared among multiple civilizations throughout the galaxy. Interstellar communication networks show evidence of coordinated activities between Earth-based civilizations and technological societies on other worlds. The communication protocols suggest that Earth civilizations participated in galactic-scale projects requiring coordination among thousands of different worlds. Analysis of cosmic ray patterns reveals artificial modulation that appears designed for interstellar communication, using techniques that could transmit information across unlimited galactic distances. The communication networks show evidence of operating continuously for millions of years while maintaining contact between civilizations separated by thousands of light years. Ancient star charts preserved in Earth's geological record show knowledge of galactic structure and stellar evolution that could only have been acquired through interstellar travel and observation. The charts include detailed information about stellar systems thousands of light years from Earth, indicating that previous civilizations achieved practical interstellar transportation. Genetic analysis of Earth life reveals biological modifications that appear designed to optimize terrestrial organisms for conditions on other worlds. These modifications suggest that Earth civilizations may have participated in galactic biological engineering projects designed to spread life throughout the galaxy. Archaeological evidence indicates that Earth served as a regional center for galactic civilization activities, hosting installations that coordinated technological development and cultural exchange among multiple star systems. Earth's position and resources may have made it naturally suitable for serving as a galactic civilization hub. Deep space monitoring systems detect regular traffic patterns that suggest continued interstellar transportation, using technologies that remain invisible to current human detection capabilities. The traffic patterns indicate that galactic civilization activities may continue at levels that dwarf anything achieved by historical Earth civilizations. Communication signals from ancient consciousness preservation systems contain references to galactic councils and interstellar governance structures that coordinate activities among technological civilizations throughout the galaxy. These governance systems appear designed to promote cooperation while respecting the autonomy of individual civilizations. Recent discoveries suggest that human civilization may be approaching technological maturity sufficient to be invited to participate in galactic community activities. The invitation protocols appear designed to activate when developing civilizations achieve specific technological and cultural milestones. The galactic context explains why Earth has repeatedly developed technological civilizations despite the apparent difficulty of achieving sustainable technology. Recent space missions indicate that some protection systems are beginning to reveal themselves to human observation, suggesting that we may be approaching technological maturity sufficient to understand and potentially integrate with these ancient defensive networks. The revelation of protection systems raises profound questions about human independence and the true nature of our relationship with previous civilizations. Our survival and development may have been carefully guided and protected by technologies operating far beyond our current understanding. The systems also appear designed to eventually transfer responsibility to successor civilizations once they achieve sufficient technological maturity. Human civilization may soon reach the point where we must assume responsibility for maintaining these protective technologies. This transition from protected development to active participation in cosmic defense systems may represent the ultimate test of whether humanity has the maturity and wisdom needed to join the community of ancient guardians, protected Earth for millions of years. Advances in quantum physics have opened entirely new methods for detecting evidence of ancient civilizations. Quantum archaeology applies principles of quantum mechanics to extract information from systems that appear to contain no recoverable data, revealing traces of technological activity that conventional archaeology cannot detect. Quantum entanglement effects preserve information about past events and quantum field fluctuations that permeate all matter and energy. This quantum information can be extracted using advanced detection techniques that read historical data from the quantum structure of materials present during ancient technological activities. Quantum archaeological techniques have recovered detailed information about technological processes that occurred millions of years ago by analyzing quantum signatures preserved in mineral crystals that witnessed ancient industrial operations. These quantum signatures provide reconstruction capabilities exceeding conventional archaeological methods. Deep quantum analysis of geological samples reveals evidence of massive quantum computing operations that operated throughout Earth's history. These ancient quantum computers appear to have used the planet's entire magnetic field and atmospheric electrical systems as computational resources, processing information on scales that dwarf current human computing capabilities. The systems show evidence of solving problems requiring computational power equivalent to using every atom on Earth as a quantum processor. Our planet may be part of a galactic system designed to continuously regenerate technological societies as part of larger cosmic development projects. Understanding Earth's role in galactic civilization provides new perspective on human significance and responsibilities. We may be inheritors of a cosmic legacy that extends far beyond our planet and includes obligations to participate in projects that span the entire galaxy. All evidence points to a critical decision point approaching for human civilization. The patterns revealed through ancient civilization research suggest that we are reaching technological and cultural thresholds that will determine whether humanity achieves sustainable long-term development or follows our predecessors into extinction. Current human technological development shows acceleration patterns that mirror those preceding the collapse of previous civilizations. Our rapid advancement in artificial intelligence, genetic engineering, and energy technologies parallels the developmental trajectories that led to the destruction of our predecessors. However, human civilization also shows unique characteristics that distinguish us from previous societies. Our global communication networks, international cooperation frameworks, and growing awareness of environmental limits represent innovations that previous civilizations appear to have lacked. The consciousness preservation systems left by previous civilizations appear designed to provide guidance during the critical transition period when developing societies must choose between sustainable development and destructive overexpansion. The guidance systems show activation patterns suggesting they are preparing to make direct contact with human civilization. Climate engineering technologies preserved in Earth's geological record provide detailed blueprints for managing planetary environmental systems sustainably. These technologies offer solutions to current environmental challenges, but require fundamental changes in how human civilization approaches technological development and resource management. Ancient warning systems embedded throughout Earth's geological record point to specific dangers that threaten all technological civilizations. These warnings focus on the management of powerful technologies, the prevention of resource conflicts, and the development of sustainable population and economic systems. The galactic civilization context suggests that successful navigation of current challenges would qualify humanity for participation in interstellar community activities. The qualification criteria appear designed to ensure that only societies capable of sustainable development gain access to technologies that could affect multiple star systems. Recent breakthroughs in quantum consciousness research suggest that humanity may soon achieve capabilities for consciousness preservation that could ensure species survival regardless of biological or planetary disasters. These capabilities represent both ultimate insurance against extinction and profound responsibilities for their ethical application. Space-based evidence indicates that human civilization is being monitored by ancient guardian systems that are prepared to intervene if we approach irreversible ecological or technological disasters. The intervention protocols appear designed to provide assistance while preserving human autonomy and learning opportunities. The choice point involves fundamental decisions about human values, priorities, and long-term goals. We must decide whether to pursue maximum technological advancement regardless of consequences or develop sustainable approaches that ensure long-term survival and qualification. Galactic community participation. Time may be limited for making these crucial decisions. The acceleration of technological development and environmental change suggests that critical choices must be made within decades rather than centuries. The window for achieving sustainable development may be narrower than we realize. The evidence from previous civilizations provides both warnings about failures to avoid and examples of achievements to emulate. Our predecessors have given us unprecedented insight into the challenges we face, the solutions that might ensure our success. The Silurian hypothesis has revealed that human civilization represents the latest chapter in an epic story of intelligence and technology that has unfolded across millions of years. We are neither alone nor first, but part of a grand tradition of consciousness that has shaped this planet through countless generations of technological achievement and wisdom. These discoveries fundamentally change our understanding of intelligence, technology, and our place in the universe. We inherit a world shaped by previous civilizations whose greatest achievement may have been ensuring that successor societies would have the knowledge and tools needed to avoid repeating their failures. The Silurian hypothesis forces us to confront profound questions about consciousness, survival, and the ultimate goals of technological development. Our predecessors achieved forms of immortality through consciousness preservation and information storage that transcend biological limitations and planetary disasters. Their message to us is clear: learn from our successes and failures, build upon our achievements, and continue the great work of expanding consciousness throughout the cosmos. The legacy of deep time challenges us to think beyond our immediate concerns and consider our responsibilities to future civilizations that will judge our stewardship of this ancient inhabited world. We stand at a critical choice point. The acceleration of our technological development mirrors patterns that preceded both the greatest achievements and most catastrophic failures of previous civilizations. Our decisions in the coming decades will determine whether humanity joins a community of successful technological consciousness or becomes another cautionary tale preserved in Earth's geological record. The wisdom of deep time suggests that consciousness represents the universe's method for understanding and managing itself. Through technological development, intelligence transforms from a biological accident into a cosmic force capable of shaping the evolution of matter, energy, and space-time itself. Our role is both humbling and inspiring. We are temporary custodians of an ancient inheritance, responsible for preserving and extending knowledge accumulated across millions of years, while adding our own contributions to the cosmic library of consciousness. The future remains unwritten, but the deep past provides both warnings about dangers to avoid and examples of achievements to emulate. Whether humanity's chapter in the story of terrestrial intelligence becomes a tale of sustainable success or tragic failure depends entirely on the choices we make with the knowledge our predecessors died to provide us.